Okay, we are going to check out the intermediate value theorem with two examples in this video. So the question is it possible to determine whether these functions have at least one real zero between a and b? So before we look at this definition, what is the question asking? So look at this function here. Is there a zero between these two values? Okay, is there a zero between those? And in order to test that, we use what we call the intermediate value theorem. It's important to become comfortable and familiar with reading math text and definitions and whatnot, but it's also important, I think, to be able to express this in your own words and really break it down, like, what is this saying? Some of the definitions, in order to be this precise, are very, very technical. Okay, so let's check this one out. This is a definition I just pulled from the book, and I abbreviated some of the things. For any polynomial function we call p of x, all right, it's semi-normal to call a polynomial function with the abbreviation of p of x to say it is in fact polynomial, right? The p. And remember, that means there are no negative exponents. There isn't any rational exponents that are not whole numbers, like 1/2 power, right? No square roots or anything like that. It has to have real coefficients, so no imaginary numbers. Not saying there might not be an imaginary zero, an imaginary solution, but the way that it's written, they will have all real coefficients. Okay, and then we are given two values, and we say a is not b because we couldn't find a zero between two values that are identical, right? Like if I said, is there a zero between 4 and 4 here? I mean, there's no number in between 4 and 4, so how can I find a zero between that? So two different values. And then if the p of a, so if I plug in a and I plug in b, and I get opposite signs, so one positive, one negative, doesn't matter the order, right? One, as long as one is positive, one is negative, then the function has at least one real zero between a and b. Let's look at what that's saying. And usually these have a little subscript or a note that follows that talks about what is not true. So, okay, let's just look really quick what's going on. So if you have some polynomial function and you plug in a and then you plug in b, I don't care if b is right here, right, or if it's way over here, it doesn't matter. We could test any two values. I mean, you could test 1.1 and 1.2, right? Let that be a and b, be that close. Or you could do 1 and 5, you know, it depends on what you want to know and how close do you want to be to find this zero. So it's saying if you plugged in a, say you get a positive, and you plug in b, you get a negative, and this is all real, there are no asymptotes, right? It's a polynomial function, then there has to be a zero in between a and b, because how do I get from here to here without crossing the x-axis? Impossible, right? Unless there was an asymptote or jump, but then it wouldn't be a polynomial function with real coefficients. Now, the side note usually says something like this. If you get the same sign, suppose they're both positive, it's not to say there isn't a zero. It's to say I can't justify, I can't make for certain if there is or is not. Okay, so just because they're both positive doesn't mean there is not a zero, right? Because this function still could have done this. But maybe it didn't, right? Maybe there is not a zero. We don't know. It's inconclusive. The same would be true as if they were both negative. I just put them in the positive. But if you get the same sign and they're both negative, maybe it crosses, right? Maybe there's a zero. Maybe there's more than one zero. But maybe there's nothing as well. We don't know. So we could only say for certain with the intermediate value theorem if we do in fact get opposite signs. All right, so let's take a look at these examples. So I'd said plug in the first value A that they give you, plug in the second value B they give you, check the signs of both. So f of A is saying do f of -3. Now, a quick side note on this one. This is a quadratic, right? It's only an x squared. I could actually just use the quadratic formula and find the zeros and then see if the value is in fact between -3 and -2. But this could have been a much more complex problem. Anything beyond 2, we don't have a quick formula to find the zeros. And in fact, even this next example is a cubic. And looking at this, honestly, I don't know how I'd factor it. I don't know how I'd find the zeros. I could graph it. You know, we do have technology now, but we're going for an understanding, right? Do you understand what the intermediate value theorem is? Not can I just plug this in a graphing calculator. So f of -3. I would have 3 multiplied by -3 squared minus 2 multiplied by -3 minus 11. That's 9 times 3 is 27 plus 6 minus 11. And we get positive. Okay, f of -3 is positive. Let's do f of b, which is f of -2. We get 3 multiplied by -2 squared minus 2 multiplied by -2 minus 11. 3 times 4 is 12 plus 4 minus 11. That's 16 minus 11 is 5. Positive. Inconclusive. Okay. So if the question is using the intermediate value theorem, determine if possible whether the function has at least one real zero between a and b, I don't know. It's not possible. There might be, but from the test, the two numbers I tested, I don't know for certain. Alrighty. So intermediate value theorem doesn't guarantee a zero. Guarantee a zero between the two values -3 and -2. All right, let's do this next one. G of 4. We get 4 to the third minus 5 times 4 squared plus 4. That's 64 minus 5 times 16. I believe we get 80 plus 4. So we get negative 68 minus 80, negative 12. Negative. G of 5. 5 to the third minus 5 times 5 squared plus 4. Well, this would be 5 to the third minus 5 to the third is 0, plus 4 is 4, so we get a positive. So yes, there is a 0. Intermediate value theorem guarantees a 0 for this function between 4 and 5. Okay, and maybe that's all I really wanted to know. Like, is there a 0 somewhere in there? Like, I'm trying to find this and I want to know when it equals 0. I think somewhere, you know, between 4 and 5. Awesome. The intermediate value theorem does guarantee that there is.